Hi, everyone. So today we are going to talk about the law of sines and how we can actually use it to solve for missing side lengths or even angle measures of triangles. And so this is not necessarily for right triangles, it could be for any triangle. But one thing we have to do a little bit of review of kind of something from geometry to figure out what we call the ambiguous case when it comes to the law of sines. Okay, so there are actually four different cases of triangles you need to look at, and it's based on what information you're actually given in the problem. So if you're given an angle, side, and an angle, so angle, side, angle. What that would look like is if you know this angle and you know this angle, and you know the side in between, you have a case number one. Or you could have angle, angle, side. So let me get a third color for that third angle. So maybe you know that yellow angle, the blue angle, and then that same side. These are the same case. This is a case where it would be appropriate to use the law of sines. Okay, case number two is when you're given side, angle, side. So you're given two sides. So side, maybe this side, an angle. And note that the other side you're given is also adjacent to the angle that you're given. So side, side, that angle needs to be squished between the two sides. This is also a case where it's appropriate to use the law of sines. All right, case number three would be if you're given three sides. So you might be given all three, side, side, side. And on your diagram, that would look something like you know this side, you know this side, and you know the third side. This is another case where it would be appropriate to use the law of sines. Now, cases 1 through 3, you do not need to worry about this ambiguous thing that is going to happen. And what I mean by ambiguous case is in case number 4, there could be more than one possible triangle that actually fits the information. There could only be one, there could actually be none. So the ambiguous case is if you're given a side, two sides, and an angle, SSA, but the angle's not adjacent to both sides. So it looks something like this, side, side, and then the angle would be somewhere out here. Okay, so this is the ambiguous case. This is the one that I would star. You have to worry about this one because like I said, there could be one, two, or no triangles that actually fit the information given. Okay, let's take a look at kind of a basic example with the formula. So let's go ahead and label this. Let's label this triangle A, B, C. Remember, using our notation, the side opposite of capital A would be lowercase a. Side opposite of big B would be lowercase b. And side opposite of big C would be lowercase c. Okay, so basically the law of sines is a ratio formula where sine of A, your angle A, divided by your side length A, should equal sine of B, angle B, divided by the length of side B, which should also equal sine of C, big C, over little c, which is the length of side C. Okay, so we're going to do a kind of simple example where we're going to use the law of sines to solve for x. Now, looking at this diagram, we're given an angle, side, and an angle, ASA. So this is not an ambiguous case. That's case number 1. So we're good to go. We don't have to worry about anything crazy. We can just directly use the formula and solve for x. Okay, now there's one catch here because the formula requires that we know the angle opposite of the side given, and the problem here is we don't actually know this third angle. But we could actually solve for it pretty easily because we know that triangles, or the sum of the angles in a triangle, add up to 180 degrees. So 70 degrees plus 30 degrees is 100 degrees. So that means that this would have to be 80 degrees, right, to add up to 180 degrees. Now we can set up our law of sines formula. So we have sine, and we know that 80 degrees is opposite of 12. So sine of 80 degrees over 12 should equal, notice opposite, opposite, those go together. Sine of 70 degrees over x. And then what we can do is cross multiply. So x times sine of 80 degrees should equal 12 times sine of 70 degrees. Divide by sine of 80 degrees. And x is about, we do 12 times sine of 70 degrees divided by sine of 80, we get about 11.450 as our answer. Okay, so that's kind of a more simple case of law of sines. We are actually going to look at a few other examples of just simple cases where they're not ambiguous, and then we'll get into the ambiguous case. Okay, so let's take a look at number 1. So we're given some information. Whenever there's no drawing, draw a diagram, label it. It will make the problem so much easier because I'll never tell you what case it is. You need to kind of figure that out by yourself. All right, so number 1, we're given that angle A is 23 degrees, angle B is 110, and C is 50, and we're asked to solve for everything. We're solving the whole triangle. So I'm going to go ahead and draw my triangle. I have A, B, and C. It doesn't have to be drawn to scale, that's okay. Angle A is 23 degrees, I'm going to label it. Angle B is 110 degrees. Angle C we don't know, but side C is 50. We don't know little a and we don't know little b. Well, this is an angle side angle case, so this is not ambiguous. This is angle side angle. I believe that was case number 1. So we're good to go. We don't have to worry about anything fancy. So we're going to go ahead and we can solve for our missing side lengths. But before we do that, we could actually pretty easily solve for angle C just using triangle angle sum. Another thing you can do is you're given information, you can already start filling in. So A is 23 degrees, B is 110 degrees, C we're about to find out, and C, side C is 50. Okay, so using triangle angle sum, we know that 110 degrees plus 23 degrees plus the measure of angle C should equal 180. Okay, so 110 plus 23 is 133 degrees plus the measure of angle C is equal to 180 degrees. Subtract 133 degrees. And we get that the measure of angle C equals, let's see, 47. 47 degrees, and we can go ahead and fill that in. Okay, so not too bad to find that missing angle measure. This is 47, we can add that into our diagram. And then we can go ahead and set up the law of sines to come up with the missing side lengths. Okay, so we have sine, of 47 degrees divided by 50, because those are opposite, right? Let's go ahead and find A first, equals sine of 23 degrees over little a. Go ahead and cross multiply. So we have A times sine of 47 degrees equals 50 times sine of 23 degrees. Divide both sides by sine of 47. And we end up with A is about, if we punch that into a calculator, 26.713. Make sure you're in degree mode. All right, similarly, we're going to solve for B. So we're going to do sine of 47 degrees over 50 is equal to sine of B, angle B is 110 over little b. Go ahead and cross multiply. B times sine of 47 equals 50 times sine of 110. Divide by sine of 47. And B, you should get, if you punch that into a calculator, is about 64.243. Make sure we always round to the 3 decimal places. Okay, let's go ahead. And actually, I think a lot of these are really similar. So you kind of get the gist of the process. Go ahead and do problems 2, 3, and 4. When you're done with them, go ahead and go to my website, mrsfitzmath.com, and look up the solutions to the remaining problems just to make sure you did them right. None of these are ambiguous cases, so you should have exactly 1 triangle for each of these. Okay, so let's go ahead and move on to some problems involving an ambiguous case. This is SSA, when you're given a side, 2 sides and an angle, where the angle is not in between the 2 sides, which does cause a little bit of a problem. And I'll show you why very shortly. So in this case, there actually could be, like I've mentioned before, there could be potentially 1, 2, or 0 triangles that actually fit the given information. So there could be 1, 2, or 0 triangles that fit the information. Okay, now the nice thing about this type of problem is that you start it in the exact same way that you did before. You are given some information, you're going to draw a triangle, and then from the drawing, you're going to start kind of figuring out all the different angle measures and side lengths that are missing. There's only one catch though, and that's where we need to be really neat with our work. So I'm going to show you a nice way to make sure that you are keeping things nice and organized. Okay, so in number 1, we're given that angle A is 45 degrees, side length A is 7 root 2, and B is 7. Okay, so from here, what we're going to go ahead and do is draw out our triangle, just like we did before. I'm going to draw it a little smaller this time, just so I have some extra room. So I have big A, B, C. Angle A is 45, little a is 7 root 2, B is 7, we don't know little c. Okay, so triangle 1. What I like to do is I like to just go ahead and write out, so A, big A is 45 degrees. B, we don't know, but I know I'm probably gonna have to approximate, I might have to approximate. We'll put big B and C. I'm not going to use an equal sign yet because I don't know if I'm going to have to round yet. Let's see. We have little a equals 7 root 2. Little b is 7, but I don't know little c. And I'm not going to put an equal sign yet because I don't know if I have to round. Okay, let's start this problem. So naturally, what you would do is you would start trying to set up some ratios in order to solve. Now, there's a little bit of an issue. We can't come up with those extra angles. We only know 1 angle. So for sure, I know I can set up law of sines where we have sine of 45 over 7 root 2, right? I know that. Now, the problem is I don't know angle B, which is opposite of my given side. So what we can do is actually set that up with law of sines. So that should equal sine of B over 7. Okay, let's keep going. Let's go ahead and solve for B. So we're going to cross multiply. We have 7 sine of 45 degrees is equal to 7 root 2 sine of B. Okay, we can divide both sides by 7. And what is sine of 45 degrees? Do we remember? It is root 2 over 2 equals root 2 times sine of b. Divide by root 2, and we have 1/2 equals sine of b, right? If I divide both sides by root 2. Now, remember, you're looking for an angle between 0 and 180 degrees. Here's why this happens to be an ambiguous case. If I'm looking for a solution to this, there are actually two answers where your y coordinate is positive 1/2 from 0 to 180 degrees. The first possible place where that happens is at 30 degrees. So b sub 1 actually equals 30 degrees. This is your first triangle. But there's another answer. It's over here. And remember, they're supplementary to each other. The second possible answer for b would be actually 150 degrees, right? Because they're supplementary to each other. But there's a little bit of a problem. We can't use 150 degrees because 150 degrees plus our 45 degrees, like if I wrote this out, if I tried to make a triangle where this is 150 and this is 45, this triangle can't exist. It violates the triangle angle sum theorem. So in this case, we actually only have one triangle. There's no second triangle. Okay, so B, we just found out, is 30 degrees. Now, pretty easily, we can come up with C using triangle angle sum. So we know this is 30 degrees. So we have 45 plus 30 plus C equals 180. 45 plus 30, we get 4, 5, 6, 75, plus C equals 180. If we subtract 75 from both sides, we get C is equal to 105 degrees. Okay, the last thing I need to do is solve for side C, which is pretty easy now that I know all three angle measures. So we do law of sines, so sine, we'll go with what we know, so 30 degrees over 7 we could use, equals sine of, let's see, 105 over C. Cross multiply, we have C times sine of 30 degrees is equal to 7 times sine of 105. Divide by sine of 30 degrees. And C is about, let's see what we get when we punch that in, 13.523. So this is a case where we only have one possible triangle. All right, let's look at a different case. Let's look at number 2. So once again, we're going to start this one out by drawing our picture and labeling what we know. So I have A, B, and C. Angle A is 43.1 degrees. Little a is 186.2. B is 248.6. We don't know little c, and we don't know two of the angles. Well, this is a side-side angle case, so this is ambiguous. There could be 0, 1, or 2 triangles that fit the given information. So let's go ahead and figure this one out. All right, let's start by setting up our ratio. So we have sine of 43.1 degrees divided by 186.2 is equal to, let's go ahead and find b, so sine of b over 248.6. All right, we cross multiply. We have 248.6 times sine of 43.1. We can't just evaluate this nicely, unfortunately. Divide by 186.2. And we're going to leave this inexact. So sine of b equals 248.6 times sine of 43.1 degrees over 186.2. Okay, so if you were to punch that into a calculator, you get approximately 0.912, which is within the range of signs. So we actually can find how many solutions if it's positive from 0 to 180 degrees. There should be 2. There will be 1 in quadrant 1 and 1 in quadrant 2. Okay, so I'm going to erase that because I'm going to run out of room real fast if I keep drawing everything out. But the first B would be the inverse sign of about 0.912. I wouldn't really round mid-problem. What I would probably do is store the actual exact answer you got for 248.6 times sine of 43.1 over 186.2. In your calculator, hit inverse sign second answer, because this is not going to be a good answer. So actually, I don't even like the fact that I wrote that way. This would just equal inverse sign of 248.6 sine of 43.1 over 186.2. Okay, so if you punch that into a calculator, your first angle, let's see, what do we get? Is about 65.819. Okay, and this would go in triangle 1. So we have A is 43.1 degrees, that was given. B, and let's call this A sub 1, B sub 1, C sub 1. Because this one, we actually probably will have a second triangle, and I'll show you how that happens in a second. So we have 65.819 degrees for B sub 1. And then let's see, A is 186.2, B is 248.6. Okay, remember, B sub 2 is supplementary. So what that means is we take 180 degrees and we can subtract off that 65.819, whatever it was in your calculator. So when you do that, you get approximately 114.181. Now you always want to check that this would actually make a real triangle. So if you notice, if you add 114.181 to 43.1, guess what? You can still, that's not over 180 degrees. It's actually less than it. So this one actually has 2 possible triangles. So we do A sub 2, which we're given 43.1 degrees. B sub 2 is about 114.181 degrees. C sub 2 we're about to find. A sub 1 is still 186, or sorry, A sub 2 is still 186.2. B sub 2 is still 248.6. Those were given. And then C sub 2 we're going to have to solve for. Okay, so you can use triangle angle sum to find those third angles for both of your triangles. So if you do that, 43.1 plus 65.819, subtract that from 180, and you get 250, what is it? Oh no, sorry, 71.081 degrees. Do the same thing for triangle 2, and for C sub 2, you get about 22.719 degrees. Okay, now for your final triangle, or for your final side that you need to find on both of those triangles, we're going to set up law of sines. So I'm going to do triangle 1 right here. I'm going to block off some space for it. So this is triangle number 1. And we can do sine of 43.1 degrees over 186.2 equals, now we're looking for side C, so we need to use angle C sub 1, which would be sine of about, and once again, I'd store this answer in your calculator. You don't really want to round mid-problem. 71.081 over, and this is C sub 1. Cross multiply. When you solve for C sub 1, you should get approximately 257.790. Okay, finally, we need to use triangle number 2. I'm going to kind of block this off from the rest of my work so I have some space. We can still use sine of 43.1 over 186.2, but this time we're using sine of big C sub 2 is 22.719 degrees over little c sub 2. Once you cross multiply and solve for that, you should get c sub 2 is about 105.243. Okay, so there is a case where we actually have two possible triangles that fit the given information. All right, so you could probably guess case or this number 3 is going to probably be no triangles, but let me show you why. So let's start just like we did all the other problems and start by drawing our diagram. We have A, B, and C. A is 42 degrees, little a is 70, little b is 122, and then we'll go from there. So once again, this is a side-side angle case, and we start setting this up just like we did the other ones. So we have sine of 42 degrees over 70 equals sine of b over 122. Cross multiply, we get 122 sine of 42 degrees equals 70 times sine of b, divide by 70. And we end up with sine of b is equal to 122 sine of 42 degrees over 70. Now let's punch this into a calculator. When you punch that whole thing in, you get about 1.166. Well, this is a major problem because the range of sine is only from -1 to 1. This is outside the range of sine. So there's actually no solution to this, which means no triangles can exist. So cross this off. This triangle cannot exist. So that's what will end up happening if you end up with a case like that. Okay, that is it for this video. Thank you so much for watching and have a good rest of your day.